Hello students, welcome in e-learning class of St. Michael's Academy. Students, in this video lecture we are going to discuss about quadratic equation. An equation of the form ax square plus bx plus c equals to 0 where a does not equals to 0 is called quadratic equation, where a, b and c are coefficients of quadratic equation. The roots of quadratic equation. Values of x which satisfies this quadratic equation are called roots of quadratic equation. Now, roots of quadratic equation ax square plus bx plus c equals to 0 are x is equal to minus b plus minus under root b square minus 4ac by 2a. Here a, b and c are real numbers, so minus b plus minus under root b square minus 4ac by 2a is also real number. Students, d equals to b square minus 4ac is called discriminant of this quadratic equation. When b square minus 4ac, that is discriminant of this quadratic equation, is positive, when b square minus 4ac is greater than 0, that is positive, then the roots of this quadratic equations are real and distinct. When b square minus 4ac equals to 0, that is d equals to 0, then roots of quadratic equation are real and equal. When d equals to b square minus 4ac is less than 0, it means that when discriminant of this quadratic equation is negative, then the roots of these quadratic equations are complex and distinct. In third case, when discriminant is negative or b square minus 4ac is less than 0, then the roots of these quadratic equations are complex and distinct. So let us discuss when discriminant is 0, that is b square minus 4ac is less than 0, then roots of quadratic equation. Students, when b square minus 4ac is less than 0, then students, when b square minus 4ac is less than 0, it means that this is negative, then minus b, then x is equal to minus b plus minus under root minus 4ac minus b square by 2a, and it is equals to minus b plus minus I under root 4ac minus b square upon 2a. And here two values are there. One we say alpha equals to, there are two values of x. One is alpha equals to minus b plus I under root 4ac minus b square upon 2a, and beta equals to minus b minus I under root 4ac minus b square upon 2a. These are the two roots of quadratic equation ax square plus bx plus c equals to 0 when discriminant of this quadratic equation b square minus 4ac is less than 0. Then roots are complex and distinct. Now, fundamental theorem of algebra. Fundamental theorem of algebra says one polynomial equation has at least one root. Fundamental theorem of algebra says one polynomial equation has at least one root. It means that a polynomial equation having degree n has n roots. It implies that a quadratic equation has exactly two roots, because quadratic equation is a polynomial equation which has degree 2. So quadratic equation have exactly two roots. Now let us solve some problems. We have a quadratic equation x square minus x minus 6 equals to 0. Now we have to find out the values of x, means root of this quadratic equation. Students, here let us find out what are the coefficients. First of all, we will write coefficient of this quadratic equation. A is equals to 1. A is the multiple of x square, and here multiple of x square is 1. Multiple of x is minus 1, and constant term c is equals to minus 6. So coefficients a, b, c. A is equals to 1, b equals to minus 1, and c equals to minus 6. Now values of quadratic equation. First of all, let us find x. Since we know values of x are minus b plus minus under root b square minus 4ac by 2a. Now putting the values of b, a and c, we will get the value of x. B is minus 1, so minus 1 plus minus under root square of minus 1 and minus 4 into a is 1 and c is minus 6 upon 2 into a. A is 1, so we will put minus 1 equals to plus 1, and this is plus minus under root square of minus 1 is 1 and minus plus, and 4 into 1 into 6 is equal to 24 upon 2 into 1 equals to 2. This is 1 plus minus under root 25 upon 2 equals to 1 plus minus under root 25 equals to 5 by 2. And there are two values of x. One is 1 plus 5 by 2 and other is 1 minus 5 by 2. 5 plus 1 is 6 and 6 by 2. This is minus 4 by 2, and this is equals to 3 and minus 2. So there are two values of x. One is 3 and other is minus 2. And these 3 minus 2. 3 and minus 2 are the roots of this quadratic equation. X square minus x minus 6 is equal to 0. Students, these roots are real and distinct. Why? Because for a equals to 1, b equals to minus 1 and c equals to minus 6, discriminant d equals to b square minus 4ac is positive. How it is positive? Because b is minus 1, square of minus 1, minus 4 into 1 into minus 6, and this is 1, this is plus 24, and this is equals to 25. This is greater than 0, so we have got real and distinct roots of this quadratic equation. If discriminant will be negative, then we will get complex root and distinct root. Now in this way, students, you can find roots of quadratic equation. You can solve this type of quadratic equations. I hope, students, you are understanding. If there will be any doubt, you can ask in comment box. Thanks.